Hi guys, welcome back. Today we will be looking at lesson 3 of section 2.1, solving one-step equations. Today we're going to be specifically looking at rules for adding and subtracting fractions. The learning objective is students will be able to solve one-step equations with fractions using addition and subtraction without the use of a calculator. And the materials for today is a notebook and a writing utensil. So the first thing we're going to look at is rules for adding and subtracting fractions when we have like denominators. So like denominators is when the denominator is the same exact number. So if we have addition, we are going to add the numerators. We're going to keep the denominators the same and then simplify the fraction if necessary. So looking at my first example here, I have 6 halves plus 1 half. So following those rules, I'm going to add my numerators, which are my top two numbers. So 6 plus 1 gives me 7. I'm going to keep the denominator, which is 2, the same, and then we could simplify this. Now, 2 does not go into 7 evenly, so I'm going to leave it as an improper fraction of 7 halves. Looking at the second one, we're going to do the same process here. The only difference is now each number is negative, but we're still adding. So I'm going to do negative 13 plus negative 2. When we do that, we're going to add 13 and 2 to get 15 and keep the negative sign. So negative 15 over, and then keep our denominator, which is 5. And we can actually reduce this, right? 5 and 15 are both multiples of 5, so I could actually divide both of these numbers by 5. And when we do that, negative 15 divided by 5 gives us negative 3. 5 divided by 5 gives us 1. So we get negative 3 over 1, or we just simply get the number negative 3. When we're doing subtraction, we're actually going to do the same exact process. The only thing that changes is that we're going to subtract our numerators instead of add them. So looking here, my numerators are 5 and 3. When I do 5 minus 3, we get the number 2. We're going to keep the denominator the same, which is 4. And then this can get reduced as well. 2 and 4 are both multiples of 2. So when I divide 2 by 2, we get the number 1. 4 divided by 2 gives us 2. So our final answer is 1 half. For the last one here, I have negative 8 sixths minus a negative 23 sixths. If you remember from the last time, if we have two negative signs directly next to each other, this turns into addition. So we actually have negative 8 sixths plus 23 over 6. So 23 is the bigger number. I'm actually going to subtract 8 from here. So when we do that, I believe we get 15 over 6. So we kept the denominators the same. Now 15 and 6 are actually both multiples of 3, so we can reduce this. I'm going to divide both numbers by 3. 15 divided by 3 gives us 5, and then 6 divided by 3 gives us 2. So our final answer here is 5 halves. The next thing we're going to look at is what happens if we have unlike denominators, meaning they are two different numbers. So according to our instructions, we're going to find the least common denominator for the fractions. We are then going to rewrite the fractions as equivalent fractions with common denominators, add or subtract, and then simplify the fraction if necessary. So looking at our first example, my denominators are 5 and 3. What I'm going to do is write out the multiples of 5 and 3 for a little bit and see if they have one in common. So if we're doing the number 5, I have 5, 10, 15, and 20. And then the number 3, we have 3, 6, 9, 12, 15. And if you notice, they are repeating, right? They both have the number 15 as a multiple. So that is going to be our fraction. Now to turn these fractions into a denominator with the number 15, we're going to have to multiply them by something. To get from 5 to 15, we have to multiply by 3. So whatever I do to my denominator, I have to do to my numerator, which is multiply 4 by 3. 4 times 3 gives us 12. 4/5 and 12/15 are equivalent fractions. Okay? Over here, to get from 3 to 15, we have to multiply by 5. So we're going to multiply the 4 by 5. 4 times 5 gives us 20. 20/15 is the equivalent fraction for 4/3. Now we can go ahead and solve this like we normally would. Now I have 12 minus 20, and we get negative 8 over 15. Okay? For the second one here, I actually have a whole number. What happens with whole numbers is that they are actually a number being divided by 1. So now we actually have two fractions. We have 2 over 1 plus 6 over 5. So we have to find the least common denominator for both of those. If I'm listing out ones, right, I have 1, 2, 3, 4, and 5. And then for 5, I have 5. And that's where we get the repeat. So notice we don't actually have to change this first fraction. It's going to stay exactly the same. What will be changing is the 2 over 1, and we want that to have a denominator of 5. Well, to get from 1 to 5, we have to multiply by 5. And same thing with our numerator. We have to multiply 2 by 5. 2 times 5 gives us 10. And now we can add our fractions. 10 plus 6 gives us 16, and we're going to keep the denominator the same, which is 5. 5 doesn't go into 16 evenly, so that is our final answer. For the last one, we have 6 and 4. So if I start listing out my multiples of 6, I have 6, 12, 18, and 24. And then I can also list out my 4s. I have 4, 8, and 12. And notice we have a repeat again, right? And the number is 12. So if I go to rewrite these, they're going to be a fraction being divided by 12. To get from 6 to 12, we have to multiply by 2. So that means we have to then multiply our 7 by 2. Now, the one thing we can't forget is that there is a negative sign here, so this fraction still stays negative. 2 times 7 gives us 14. Now, if I'm looking at my 1/4, to get from 4 to 12, we have to multiply by 3. So I'm going to multiply my 1 by 3. And 1 times 3 is 3. Negative 14 plus 3 gives us negative 11. And then we keep the denominator the same, which is 12. And we cannot reduce this either, as they don't have any common multiples. Okay? So now we're going to use this information to solve for some equations. Now, if you think you guys can figure out how to do this on your own, I would recommend pausing the video, try them out, see if you get them correct, and then unpause the video to see what the answers are, because I'm going to do them right now. So looking here, I notice I have two fractions and they are the same denominator. So I'm not going to change anything with these fractions. I'm just going to solve the equation. I have n plus 5/6 is equal to negative 1/6. To get n by itself, I'm going to have to subtract our fraction. So when I subtract 5/6, I'm going to do it to the other side as well. A positive 5/6 minus 5/6 cancels out, and we get n is equal to, now sometimes this looks a little tricky when they're stacked on top of each other. So I'm going to rewrite it out over here. So negative 1 minus 5 will give us negative 6, and then the denominators stay the same. Notice -6 divided by 6 can be reduced, and what ends up happening is when we reduce it, we get the number -1. So n is equal to -1. That's our answer there. For the second one, just quickly looking, right, denominators are still the same. So we don't have to change any of the fractions. We have m minus 5/4 is equal to 37/4. So I can add, because I'm undoing my subtraction, 5/4. The left side's gonna cancel because they're opposites. We get m is equal to, now these we can just add. 37 plus 5 is going to give us 42/4. Now looking at this fraction, I know right off the bat they're both multiples of 2. So to reduce this, I'm going to divide by 2 each number. When I do that, I get 21/2. Then when I look at 21/2, I'm looking, can anything go into those two numbers? And the answer to that is no. So this is our final reduced fraction for our answer. For number 3 here, I have a whole number and a fraction. So that tells me I'm gonna have to rewrite some stuff. So I'm gonna make my -2 a fraction over 1. And then when I look, I'm like, okay, they have different denominators. Now I want the denominators to be the same. 2 and 1, if I start listing them out, right? 1 is 1, 2, 3. 2 would give me a 2, so they have a 2 in common. I don't have to rewrite my -7/2. That's gonna stay the same because it already has a denominator of 2. What has to change is my -2/1. Since 1 times 2 gives me a denominator of 2, I'm gonna have to multiply my -2 by 2, and we get -4. Now that we've changed everything here, and they have the same denominator, I can now solve. I'm subtracting, so I am going to add 4/2. Okay, the right side is gonna cancel. I'm going to carry my work on over here. I have -7/2 plus 4/2. So -7 plus 4 is going to give me -3. Denominator stays the same. And what's left here on the right hand side is n. So -3/2 is equal to n. That is our answer. For the last one here, again, they have different denominators. So what I can do is list them out. So 2, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. For 11, I have 11, 22, and 33. So if you notice, we have a repeat of the number 22. What's great about this is we don't actually have to change 19/22. It's already written with that denominator. What does have to change now is the 3/2. So to get from 2 to 22, we actually have to multiply by 11. And so we can actually multiply 3 by 11 as well. And 3 times 11 gives us 33. And then I bring down my plus n. Since I'm adding 33 divided by 22, I am going to actually subtract it. The left side is going to cancel. We're going to be left with n is equal to, now 19 minus 33, okay? The 33 is negative, the 19 is positive. So what we can do is take the absolute values if we're stuck. So what I'm going to do is I'm going to actually take the absolute value of negative 33 and then subtract it from the absolute value of 19. So we get 33 minus 19, which gives us, let me see, That gives us, I believe it is 14. Okay, and then because our bigger number is negative, our final answer here is going to be negative 14, and then we keep the denominator, which is 22. Now looking here, they're both even numbers, so they can both be divided by 2 as a way to reduce. Okay, negative 14 divided by 2 gives us negative 7. 22 divided by 2 gives us positive 11. So that is our final answer. Okay, that is it for today's lesson. I hope you guys have a great rest of your day. Bye guys.